Welcome to SciCuriousID, where we explore the fascinating mysteries of our universe. We've all learned that light travels in straight lines, a fundamental principle taught from an early age. But what if I told you that's not always true? Under the right conditions, light can bend, curve, and even sneak around corners. Sounds like magic? It's not. It's pure physics. Today, we'll uncover how the universe lets light cheat geometry itself.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
For centuries, scientists debated the true nature of light. Isaac Newton, for instance, believed light was made of particles that moved in perfectly straight lines. However, in the early 1800s, Thomas Young performed his famous double-slit experiment, a groundbreaking demonstration. This experiment conclusively proved that light behaves like a wave, not just particles. This discovery opened the door to understanding one of light's strangest properties, diffraction. Diffraction is the reason light can bend around edges, a phenomenon where light waves spread out after encountering an obstacle or a narrow slit. Instead of stopping sharply, the waves bend into the shadowed region. The smaller the obstacle compared to the light's wavelength, the more pronounced this bending becomes. For visible light, this effect is tiny because its wavelength is only about 400 to 700 nanometers, making the bending subtle. But with fine edges or microscopic gaps, the wavefronts overlap and interfere, making the light appear to bend around corners. This is why, even though your flashlight beam seems straight, some light still illuminates faintly behind thin objects. It's also why shadows aren't perfectly sharp. Light diffracts slightly along the edge, blurring the boundary. You can observe this effect by shining a laser through a single strand of hair. You'll get a beautiful interference pattern that reveals the wave nature of light. Diffraction isn't just a lab curiosity. It's behind the shimmering colors on CDs, DVDs, and even soap bubbles. Those rainbow ripples are light waves interfering with each other after bending and reflecting in thin layers. And a fun fact, some animals, like butterflies and beetles, use microscopic structures on their wings to diffract light intentionally. This creates brilliant iridescent colors that don't fade like pigment, a natural marvel of physics. Sound waves bend easily around corners because their wavelengths are much larger than those of light. For light, it takes extreme precision or nanotechnology to make diffraction visible at human scales. Scientists today use this principle to develop cloaking devices that guide light perfectly around objects, making them nearly invisible. Yes, real invisibility, powered by diffraction and metamaterials, is becoming a reality. So, next time you see light softly glowing behind an edge, remember it's not disobedience, it's diffraction. Light is far more flexible than we ever imagined. Curious for more? Subscribe and stay curious with SciCuriousID.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.